Back to questions in the room. Yes.
Hello, Adi Nauw from Astroblogs, Netherlands. I have a question about the accretion disk of black holes. All black holes seem to have an accretion disk. Did you try to have an image of that accretion disk too? And how do I see the accretion disk compared to this image? Is it outside of this horizon, or I don't know?
So, as you correctly said, these black holes are not in vacuum. They are surrounded by matter, and matter naturally folds and circles around it. Now, in this very image, the accretion disk is essentially as my hand. We're seeing it almost face on. And so it happens that matter that rotates in particularly in clockwise direction, will be pushing towards us. It's all of its emission, and this is why the bottom line is more bright than the top part, because it's what is called Doppler beamed. It's more intense because of a relativistic effect. So you can imagine that there is matter going around in a clockwise in a kind of accretion disk. The disk is not thin as we normally see in science fiction. It's a very thick accretion disk, and the simulation that you will find online will clarify this a bit better.
I would like to add here that it is okay to, this image can have different interpretation, and it is possible that we are actually, that this ring is actually the inner edge of the accretion disk.
Or the inner edge of the jet. That's where it starts. The problem that we have is that the light bending actually blends everything together. So when you look at low radio frequencies, you see the jet. As you go to high frequency, you get closer and closer to the event horizon. That's why I went to this high frequency, because that's where we actually start engulfing the entire black hole. That's where we can resolve the black hole, but that's where the innermost region is, and then everything gets blended together by light bending. So if you look again at the simulations, then you get a much better idea of what we think there is.